So after discussing the qualities of a satisfactory protective relay system, these are the different types of power relays. This is Lester R. de Guzman report. Electromechanical relays, a conventional type of relay which uses an electromagnet to turn on or off the circuit. Most of the relays are used to protect the system in power system industries, which are operated by current or voltage. They are classified into electromagnetic attraction type relay and electromagnetic induction type relay. For the electromagnetic attraction type, the magnetic force produced by undesired current attracts the armature of the relay. Electromagnetic attraction type relays can operate on either AC or DC quantities. They are classified into attracted armature type, solenoid type, and balanced beam type. Electromagnetic induction type. The working mechanism of induction type relays relies on the electromagnetic induction phenomenon. They are only used in AC quantities. They are classified into shaded pole type structure, watt-ammeter type structure, and induction cup type structure. The advantages and disadvantages of electromechanical relays. Advantages are simple, robust, and compact. They are low cost. They have high operating speed. They are used for both AC and DC systems. They can withstand high voltages. It provides physical isolation with minimal voltage drop and minimal damage from leakage current. However, the disadvantages are generates noise due to its mechanical parts. They have limited lifetime, and they are slow because of the mechanical parts when compared to semiconductor-based relays. The applications of electromechanical relays are used for the protection of various AC and DC equipment, used for motor control and automotive applications, and for controlling large power loads in industrial applications. The next one is the solid-state relays, an electronic switching device that switches on or off when a small external voltage is applied across its contact terminals. It does not have a moving contact, unlike electromechanical relays. The solid-state relays of semiconductor switching elements such as diodes, triacs, transistors, and thyristors. This is the working principle of the solid-state relay. For the advantages and disadvantages, the advantages are they have faster switching speeds, they have no physical contact to wear out, there are no mechanical parts and thus noiseless, lifetime is higher, they have greater resistance to vibration or shock, and they are useful for high voltage applications. However, the disadvantages are they are not robust, they are relatively more expensive, they dissipate more heat, and they are highly susceptible to surge currents and damage when at signal levels of above their rating. These are the application of solid-state relays. They are widely used for switching DC and AC circuits, used in process controls industries, communication lines, and power switching, and others. So these are the types of relays based on logic of operation. First one is directional relays. They are the type of relays to operate on the direction of the current and power. They're classified into the reverse current directional relays and reverse power directional relays. Next one is distance relays. Distance relays contains two coils, one of which is energized using current and another one using voltage. The voltage to current ratio is measured, and working of distance relays is based on this voltage to current ratio. They are classified into admittance, impedance, and reactance distance relays. And lastly, differential relays compares the difference of quantity entering and leaving the system. They are classified into current balanced differential relays and voltage balanced differential relays. Next one is the types of relay based on time or the delay time. First one is instantaneous relays, in which there is no time delay provided intentionally. Next one is definite time lag relays, which are those which operates after a specific time. The last one is inverse time lag relays, which is the one which operates approximately inversely proportional to the magnitude of the actuating quantity. It is also referred to as the inverse definite minimum time or IDMT relay. It applies a time grading mechanism. These are the types of relay based on application. We compare primary and backup relay. Primary relay, also known as the primary protection relay, is the first line of power system protection, whereas backup relay is operated only when primary relay fails to be operated during a fault. Hence, backup relay is slower in action than primary relay. As because backup relay operates only when primary relay falls, backup protection relay should not have anything common with primary protection relay. These are the conditions for failure of a relation of a relay. First one is the protective relay itself is defective, or DC trip voltage supply to the relay is unavailable. Trip led from relay panel to the circuit breaker is disconnected. The trip coil in the circuit breaker is disconnected or defective. Or lastly, current or voltage signals from current transformers and potential transformers are unavailable. These are the examples of the usage of relays in transmission and distribution lines protection. They are either used in 400, 220, or 132 kilovolts transmission lines, as well as in 33 and 11 kilovolts lines. They are also used in transformers, such as in generator and station transformers. And that's it for my report. Thank you.